Okay, let's continue example 1. So this is what I wrote from the last part. And let me go ahead and just write the initial conditions, since that is going to be our next step to use these guys. So x of 0 is 2 and x prime of 0 equals -1. Okay, so here's again, my differential equation, right? This is after taking the Laplace transform of my second derivative, right, is this expression, minus, right, the Laplace transform of the first derivative, which is this guy. And actually, so to be safe here, I'm going to go ahead and write parentheses around that, because we're subtracting that whole expression. Okay, so let's use our initial conditions. Wherever we see x of 0, right, we put 2, and wherever we see x prime of 0, we input -1. Okay, so we have s squared, chi of s, minus s times x of 0, and that looks like it is 2 minus x prime of 0, so that's minus 1. And here we have minus, and then s times chi of s, so s times chi of s, minus x of 0, which is 2, and I'll go ahead and just make this smaller so it'll be one line, minus 6 chi of s equals, that's an s, 0. Okay, so again, just simplifying, right, using some arithmetic. So this is minus 2s plus 1, and then I'm going to distribute that -1, right? So I get plus 2 minus 6 times chi of s equals 0. Okay, so now I want to combine my chi of s's together, because usually after you distribute, you can combine some like terms. So I definitely have chi of s here and chi of s. So that's my greatest common factor. So I'm going to have s squared, right? So I'm factoring chi of s, and I'm left with s squared, right, minus s minus 6. And let's see, I can save some room here. So chi of s, and I'm just left with minus 2s, and then of course 2 plus 1 is 3, equals 0. Okay, again, our goal is to find small, right, x of t. That's the solution to the differential equation. So we have this chi of s, which is really our capital F of s. And we're going to be using the inverse Laplace transform. But right now, let's go ahead and solve for for chi of s. And so if I solve for chi of s, I'm just going to move, right, hopefully you guys can see, this is just some algebra. I'm moving my 2s, right, adding 2s and subtracting 3 to both sides, and then I'm definitely going to divide by s squared minus s minus 6. And this is where partial fraction decomposition is going to become very handy, because, again, our goal is to find x of s. We have x prime of s, which is this expression. This is a nice trinomial, which should remind you of factoring. So we can definitely factor the denominator. And we have our two binomials, right? And we're going to get s minus 3 and s plus 2. And this is where partial fractions comes very handy. We're going to split this guy up, and let me actually make this a little bit smaller so you can see the full equation. So I want this to be, it's going to be the sum of two fractions, right, with some constant a and some constant b. And I mean, this is again minus. And again, if we multiply this expression, right, by s minus 3 and s plus 2, or, I mean, we know, right, this guy needs an s plus 2 in order to add the fractions. This guy needs a s minus 3, right? And notice the denominators, I mean, they're the same, right? So we're allowed to add these. So we get, from here, we get 2s minus 3 equals a times the quantity s plus 2 and this guy. Okay, so let's find our a and b. So if S is, let's say, -2. Okay, so I'm going to substitute, right? 2 times -2 minus 3 equals, this is really -2 plus 2 plus B. S is -2 minus 3. And this is -4 minus 3. This is gone. I'm get left with -5B. -5B is -7. That's a 7. And that is equal to negative, that's a 5. So if we solve for B, right, B is equal to 7/5. So similarly, we can find our A. So if S is maybe 3, we get 2 times 3 minus 3 equals 3 plus 2, and then we know this guy is going to be gone because 3 minus 3 is 0, which is what we want. And let's see, we're left with 6 minus 3 is 3, and that's 5A, so therefore A is 3/5. Okay, so now let's substitute our coefficients A and B back into our equation. So let me go ahead and rewrite chi of S. So we know chi of S, when we solved for it, right, using partial fractions, well, when we determined our A and B, okay, so we had S minus 3, and we had S plus 2, and our A, right, is 3/5, and our B is 7/5. Okay, so we have chi of S, but our original equation is, if we look, I mean, the original equation is x of t, right? Small x of t. So this is not x of t. This is chi of S, or capital X of S. So remember, right, this should remind you of f of S, and we want to go back to x of S, small x of S, so we need to take the Laplace inverse of this function in order to obtain our solution. So I'm going to take the Laplace, let's see, maybe inverse, right, of this guy, which is going to be the Laplace inverse of this guy, and we did some of this in 4.1, or pieces of it. Okay, so property of linearity again. We can definitely take out the constant, right? That's okay. So the Laplace inverse of 1 over S minus 3 plus, and again, I'm going to just take out that 7/5 times the Laplace inverse of 1 over S plus 2. And so now we ask ourselves, get my white here, what is the Laplace inverse of this guy, and what is the Laplace inverse of this guy? So we go back to our table on page 271, and I'm looking, so on page 271, and again, we have f of t and capital F of S, that's the Laplace of f of t, and the only denominator that looks very similar to ours is 1 over S minus A. So when f of t is e to the at, I get 1 over S minus A. So I know that the Laplace transform of this guy is this guy. Or another way of saying this is the Laplace inverse of 1 over S minus A is equal to e to the at, right? We're just going, again, backwards. Okay, so knowing that, let's just continue this guy. So I have 3/5, and I have 1 over S minus 3. Well, my A is definitely 3, so I have e to the 3t plus 7/5, and this guy is really 1 over S minus 2, right? That makes a positive. So S minus, so my A here is -2, so it's just e to the -2t. And I'm just turning back to see if that is correct. That should be the answer. Yep, so this is our solution to our IVP, initial value problem. And again, notice this guy is small x of t, right? Here's your solution to the differential equation. So remember to take the Laplace inverse of that.